Implementing 802.1x authentication. Let's begin. In our previous video together, we identified three roles these devices can play inside of 802.1x. A supplicant that supplies credentials, the authenticator who's requesting those, and then the authentication server that has the ability to give the two thumbs up saying, yes, that's the perfect authentication, let that user in. And secondly, if we configure it, we can also configure authorization. For example, if Bob is the end user here and we're using his credentials as a supplicant, the protocol used here is EAP, the Extensible Authentication Protocol. And really that's a framework. When people talk about EAP, there's a boatload of different protocols that we could be using. But the basics are that when this PC powers up, when that link comes up on the switch port, if that port is configured as an authenticator, it's going to send an EAP request, effectively saying, hey, who are you? Like the song, Who Are You? Once that EAP request asking, who are you, goes out, if there is a supplicant running on this system, it can send back an answer to identify the credentials of the user or the system that's hanging off of this port. And then the switch takes that information and then can forward it over to our AAA server, in this case the authentication server being run on ICE. And the protocol here is using Radius. Now, as we know, the bummer with Radius is that most of the content is in clear text. So if we want to protect, for example, the credentials and the other information being sent from the authenticator over to the authentication server, we could use something called tunneled Extensible Authentication Protocol. So this green line is going to represent basic Extensible Authentication Protocol that has the username and the credentials for Bob. And we want to get that information all the way over to the ICE server, the AAA server acting as the authentication server. Well, if we use tunneled EAP, we could go ahead and put that entire conversation inside something that could protect the contents of that all the way across. And so this blue outer shell could represent, for example, a flavor of EAP called Protected EAP, so PEAP. And using the protection that Transport Layer Security brings us, we then have the confidentiality and the data integrity for the entire session over to the authentication server. So the authenticator and the authentication server are still using Radius as a communications mechanism back and forth, but the contents being delivered is the protected EAP. Now, if we're using protected EAP with TLS, TLS implies that we have some digital certificates in place. Another option, of course, we have, instead of using a self-signed certificate on the ICE server, is we could go ahead and get a certificate, an identity certificate from a CA. So let's imagine that Bob's computer connected, the EAP request was sent, they're using PEAP to protect the entire conversation, and Bob is authenticated. Once Bob's authenticated, we can also use the features of authorization, and we can push down policy from the authentication server, in this case ICE, over to the switch to be applied to that switch port. For example, we could say, oh, it's Bob, let's put him in VLAN 15, or hey, it's Bob, let's put him in VLAN 20. All that can be configured on our ICE server. Or we could configure downloadable ACLs based on Bob's authentication, or specific access based on the time of day or the day of the week. And if our switch supports it and our AAA server, the ICE server, is configured to deliver it, we could also implement TrustSec capabilities as well. Now you might ask, okay, Keith, what exactly are TrustSec capabilities? One of those aspects would be, for example, security group ACLs. And those define specific ACL policies for a group of devices instead of a single IP address. And with TrustSec, we can work with security group tags. And SXP is an acronym for security group tags, as the S part, exchange protocol. A few of the flavors regarding EAP, we have EAP TLS, which is for EAP Transport Layer Security. And anytime we see TLS, I want you to remember that there's a certificate involved. That's also true for Protected EAP. Those both require server-side certificates. There's an EAP for MS Chat version 2, which would imply it works very well with Microsoft products, including Active Directory. We have EAP Fast, which sounds like, ooh, that's going to be really quick. Well, the FAST is simply an acronym that stands for the Flexible Authentication via Secure Tunneling. So for example here, if we wanted to secure the communications instead of using PEEP, we could use EAP Fast. And behind the scenes, EAP Fast also uses TLS, which again implies that we've got a digital certificate in use on the ICE server for that authentication of the server. And EAP Fast is an implementation that was created by Cisco. And if you're in a really older environment, there's also Leap. Now, Leap is also a Cisco creation, and it's been basically replaced by EAP Fast. And Leap was created a long time ago before the standards were set. And what Leap did, it used a modified version of MS-CHAP. So it wasn't literally MS-CHAP, but it was a modified version of it for its early edition called Leap. And today, most people are not going to be using Leap. They'll be using EAP Fast or Protected EAP. But we're still going to give a shout out for Leap because it was one of the early protocols to help improve security with 802.1x. And the creation of PEEP was a joint effort between Cisco, Microsoft, and RSA Security. Let's do a quick check to make sure we're on the same sheet of music. We have our supplicant, which is requesting access to the network. It wants to get in through this port. And in a secure environment, this port on this switch, who's acting as the authenticator, we may allow EAP traffic if we want to hear from this supplicant who's talking to us. We might want to allow DHCP. So the job of the authenticator is to go ahead and simply restrict virtually all traffic until that client successfully authenticates by sending credentials. Those credentials are passed over to the AAA server, and then the AAA server says yes. And then if we set up authorization as well, can push policies such as VLAN assignment, downloadable ACLs, or trust set components regarding what the user, in this case Bob, can go ahead and send and receive over that port that he's connected to. So the policy is going to be configured on the ICE server and it's going to be implemented on the authenticator. The other thing from a practical perspective is that if you and I are deploying 802.1x, where are we going to deploy this first? It's very likely we're going to want to deploy it in a test environment with end users or devices that are not critical. I was chatting with a colleague the other day and he was talking to me about rolling out 802.1x. He says, oh my goodness, we made a huge mistake. I said, what? What happened? He said, we rolled out 802.1x and it started cutting off the traffic from our critical users. For example, the senior executives and so forth. They couldn't access what they needed to on the network. And he said, in retrospect, what we should have done is we should have started off really easy. For example, in like monitor mode. And here's what monitor mode is all about. We tell the port that it is basically open for business. We're going to run the authentication for 802.1x. We're going to run the authorization, but we're not going to enforce negative consequences if it doesn't go well. That way we can see what's happening, look at the debugs, look at the accounting records, and make changes. So as we roll out our 802.1x, and what we're going to do in this course is we're going to take a look at using monitor mode, which is effectively saying that we are open in the port configuration. And then once we have that set up, maybe the next step is a low impact. And with low impact, we could go ahead and use basic access control lists. And we can apply those access control lists directly to the switch ports. And we would do that while we're still in open modes. So we're simply gradually adding restrictions to test the waters. And then finally, when we're done, we can go ahead and simply say that port is completely under the control of .1x. So maybe we still have an access control list that's allowing, for example, DHCP traffic and so forth, but we're no longer going to say the port is open for business. There has to be a user or a device that authenticates via a supplicant or through some other authentication method before we allow traffic, production traffic, transit traffic through that port. And we can call that model closed, suggesting that traffic for all intents and purposes is not allowed. We are closed for business until you've authenticated. So we call this easy or open. Low impact would be open plus access control list on the port. And then closed is effectively you're not getting in, nothing's happening until you authenticate. So another term that also comes up is EAPOL. And you might think, okay, what exactly is that? Is that server-side certificates? Is it tunneling? What is it doing? Extensible Authentication Protocol over local area networks. Then we'd have to dig into the details to see exactly, okay, how are we going to deploy this? We're going to use FAST or PEEP or some other flavor of EAP. So EAPOL is simply a general term for using EAP on a local area network. There's also an issue that we actually have two devices out here or more that might need authentication. For example, we might have Bob the user and PC1, which is Bob's machine. And we very well might want to authenticate both of those entities before allowing communications through the network. And Cisco has come up with a method for including the EAP conversations for authenticating a user as well as the computer over a single tunnel that's going between those devices and the ICE server. And they refer to this as chaining. And to do that currently with the Cisco solution, you have to use EAP-FAST. There are some standards that are being worked on, but until they're out and everybody supports them, if you want to do chaining of the authentication for EAP of the user and the hardware, the outside tunnel for that authentication is going to have to be EAP-FAST. And then using that EAP-FAST, we could have the EAP, for example, for Bob and the EAP for the PC, both using the protection of that one EAP-FAST tunnel. One thing I've noticed about switch ports is that we can dangle a lot of stuff off of a single port. For example, we might have a PC that's running here, which would be one device, or that one PC could be running a hypervisor. We could have multiple virtual machines running inside that operating system. So we have guest number 1, 2, and 3. However, we also have devices like IP telephones. So coming from this switch, we might have a connection that goes to the phone, and then there's a little switch built into the phone that goes to the PC. And now we're going to have multiple MAC addresses. And likely multiple VLANs. A VLAN for the data traffic from the PC and a VLAN for the voice traffic, a voice VLAN. And because we need to be prepared as far as 802.1x is concerned for all those scenarios, we have several modes that we can configure regarding the authenticator for the port that leads out to that device or those devices. The single host is exactly what it sounds like, a single MAC address. So the link comes up, we're going to go ahead and send an EAP request, or if there's a supplicant, it's going to go ahead and supply information. And once we authenticate a single MAC address, that's it. No additional MAC addresses are going to be allowed nor authenticated via 802.1x. Which reminds me of the movie of Hunt for Red October when Sean Connery says, "One ping only." I think one MAC address only is going to be authenticated on that switch port if it's in single host mode. Next we have multiple host mode, which is a little bit crazy. And the way that multi-host works is this. If we have a single MAC address that authenticates, it's like that first MAC address opened the door, and now all the other MAC addresses are allowed to go through that port without any type of authentication and authorization required. So imagine this environment where we have the host operating system and 3 guest virtual machines all bridged to the outside interface of the host. The supplicant for the PC authenticates. The port is open via the authorization controls for 802.1x. And now all these other virtual machines and other MAC addresses are allowed to go ahead and forward traffic through that port. Next we have multiple domain mode. It's also referred to as MDA for multiple domain authentication. This domain is referring to the domains of voice and data. It has nothing to do with like Active Directory domains or anything like that. It's simply referring to the fact that you may have a voice over IP device like a telephone, And you also may have a computer that needs to get on the data network, and that would be the two domains, voice and data. And in multi-domain mode, it's going to allow the authentication of one MAC address out of the voice VLAN and one MAC address out of the data VLAN. They could have called this the one each mode. And then we have multi-authentication mode. And with multi-auth mode, what we're doing is we're saying at the switch port that every single MAC address, no matter how many there are, need to be authenticated. So if this host computer with 3 virtual machines, which are all bridged to the outside interface of the host, to the switch, it simply looks like 4 different MAC addresses, and each of those MAC addresses, before they get access through that switch port, they are going to have to authenticate. And the way to authenticate is with a supplicant. So each of those devices, the 3 virtual machines and the host, would each need to have their own supplicant with their credentials so they could go ahead and authenticate. Now, there is another option that we can use, and that is called MAC address bypass. And MAC address bypass, it isn't really a formal type of authentication in my opinion. And here's how it would play out. Let's say we have a port right here and it goes up to a printer. Now, most printers are not going to have a built-in supplicant as part of their operating system. And most printers do not have the option of adding a supplicant. For example, Cisco's AnyConnect or some other type of supplicant software, because they are a printer. That's what they do for a living. So on this port, what we could do is we could specify that 802.1x is required. However, if there's a timeout, for example, the switch says, "Hey, who are you?" And the printer says this. Crickets. Nothing. Because it doesn't have a supplicant. It doesn't speak EAP. So it doesn't send any message. After a timeout, we can go ahead and fail over to MAC address bypass for authentication. And if we've configured MAC address bypass with the MAC address of that specific printer, the switch, after the EAP times out because the printer is not responding to it, it can then go ahead and take the MAC address of that printer and forward it over to the AAA server and simply ask the question, "Hey, here's this MAC address, is it okay?" And if the ICE server gives 2 thumbs up saying, "Yep, that's already pre-programmed, I know that's a printer, let him in." Then that port can transition to an open state to allow that printer to communicate on the network. So here's what we get to do as far as a demonstration for this video. We're going to configure this port, which is port gig 0/7, to be set up as an authenticator port that can be used with 802.1x. In our previous video, we configured the radius relationship between this switch, which was switch number 1, and that switch is at 192.168.1.121. And the ICE server, which is at .117. Also, in the previous video, I identified what the issue was. The ICE server, which is running as part of VMware Workstation, was on a machine that had a wireless repeater that was connecting it over to where the physical switch was. And that wireless repeater was at the edge of its limits. So what I did between the previous video and this one is I simply put the switch, here's switch number 1, and our ICE server, which is running virtualized instead of VMware Workstation. I put them on the same physical network. So they're both on the same layer 2 broadcast domain, the same VLAN, and they're both on the same network, 192.168.1.0. And there's nothing like a wireless repeater that's impeding their progress in communicating back and forth with each other. Also, in our previous video, we created a user account called Bob on the ICE local server, and we set up the password as nugget!23. And the reason I point that out, and the reason in the previous video we did our basic test of radius between the ICE and the switch, is because I wanted to point out that by using the defaults, we can get up and running with basic 802.1x authentication without a lot of additional configuration on the ICE server. What we do get to do is we're going to configure a little bit of detail regarding 802.1x authentication on the port gig 0/7. And we'll also need to configure a little bit of detail on the supplicant that's built into the Windows computer so that the supplicant can supply the correct details, the correct credentials over to the authenticator, who's going to then forward them over to the AAA server. And to do that, we're going to go ahead and use an outside tunnel of PEEP, Protected EAP. So because we're going to be using PEEP and we have a self-signed certificate on the ICE server, I'm also going to tell the supplicant that's running on my Windows computer, hey, you know what, don't bother worrying about verifying whether that certificate's valid or not. Just go ahead and accept it. And then in another video, we'll take a look at integrating a certificate authority and actually deploying specific certificates on the ICE server. But for now, we'll simply tell the Windows computer to look the other way regarding the verification of the certificate of the ICE server as we use PEEP. Alright, let's get this party started. We're going to start off with a basic ping test just to validate that the communications between the switch at .121 and the ICE server at .117 are completely solid. So we'll do a quick ping, and that looks great. And just for grins, let's also go ahead and verify that the basic AAA services that we set up in our previous video are still in place. We'll do that with a test AAA group, the name of the group, the name of the user Bob, the password of Bob, and new dash code, and that looks great. Next, let's set up a method list for .1x. Now, we could create multiple method lists, or we could set up the default method list. Let's use a default method list here and say, Dear Mr. Switch, if you ever need to do authentication regarding .1x, we want the default method list to be one of your Radius servers that's in one of your Radius groups. We could call out a specific Radius group if we wanted to as well. We have one Radius group, it's got one Radius server. So the switch is pretty clear at this moment on who it would call on if it needs to do .1x authentication requests. Now, authentication is great. It's like the gateway drug to authorization because we need to know who a user is before we can authorize them for specific services. So the second piece that we're going to do is we're going to add on AAA authorization for network access. Now, network access could refer to somebody connecting to a line, or in our case, a user who's trying to connect to a switch port. And it's the authorization component that, after we configure those additional parts and pieces up on the AAA server, the ICE server, we can have those pushed down to the port once that user has authenticated. The authorization portion adds the details such as dynamic access control list, what VLAN you belong to, and so forth. Now, because we are going to do some accounting as well, let's also use our ICE server as an accounting server regarding .1x. So we'll specify the default method list for accounting regarding .1x with AAA accounting .1x default start-stop group radius. One of the reasons that Radius is so darn flexible is that we have a lot of attributes that we can add or remove, including vendor-specific attributes. And in our case, even though we're not going to be using it right now, I want to go ahead and include the IP address of a host that's trying to authenticate, a supplicant that's trying to authenticate, as part of the authentication requests that go over to the ICE server. So by using the command radius-server attribute 8 include-in-access-rec, that will include the IP address of the supplicant as part of the request. The other thing we want to do on this switch here in global configuration is tell the switch that we want to go ahead and be able to use authorization control via .1x. That way, when we go to a switch port and we say, okay, we want this port to be under the control of .1x, because the functions enabled globally, we have the opportunity to configure individual ports for that feature. So to globally enable it, the command is .1x system-auth-control. Now, if you, like me, when learning new information, frantically take notes, I like that. It's a great idea. Writing out notes is helpful in remembering commands and how they work and so forth. But I'd also like to share something with you. These commands that I'm using right now, I've also included in a document called Basic Switch 802.1x Configs that are part of the Nugget Lab files. So if you want to download the Nugget Lab files and use these commands that we're doing in this demonstration as a review process, they're there for you if you want to go ahead and use them. Now it's time to dive into a port and to configure a port specifically to be used with 802.1x. But what I'd like to do is wipe it out completely so that you and I both know there's nothing there except for the defaults. So we can do that with default interface gig 0/7. Now that is not a good one to do in a production environment on a port that you currently have well configured, because it's going to wipe everything out. But in a lab environment or on a new port where no devices are actively working yet, it's a fantastic way of clearing any non-default configuration that is currently on that switch port. Let's also go ahead and shut down that port so it's in a nice steady down state until we're ready to bring it up. One thing we're definitely going to want to do is set this port as an access port. So using the command switch port host on this switch does two things. It turns on spanning tree port fast, so we're not in a delay for listening and learning, as well as it's going to go ahead and make it an access port. So the one required one is the access port, and the other option with port fast is simply so we don't go crazy waiting for the timeout with spanning tree. Because we will be bringing up and bringing down this port frequently as we work with and test 802.1x. And for good measure, let's do a show command for interface gig 0/7 with the show run interface gig 0/7. So there's our basic configuration so far for that port. So let's specify who has to authenticate. And in our case, in our lab, I'm going to set up multi-authentication, meaning every MAC address has to go ahead and be authenticated before that traffic from that MAC address will be allowed through the switch port. And the syntax for that is authentication, host-mode, multi-auth. Now, because we are going to start off slow, we're not going to lock down the port and say, nothing gets in. Let's go ahead and set up the authentication as open. Now, what open means is that even if 802.1x fails, we're not going to go ahead and close down the port. So whatever VLAN that port is currently assigned to, by default it's VLAN 1. If there's a DHCP server there handing out IP addresses, and if the client's a DHCP client, even if authentication fails, with the open option, everything still works. And you might ask, well, Keith, what's the benefit of that? And the benefit of that is keeping our jobs, because we definitely want to test before we actually start locking stuff down, because a user in motion, a CEO in motion, wants to stay in motion. We don't want to cut off people's production traffic accidentally or cut them off from their networks until we're sure we have a full working solution. So that's what we're going to do in our test environment to begin with. We'll go ahead and say authentication open as we start warming up and verifying that things are working. We can also specify that once an entity has been authenticated, a supplicant has provided credentials, we could also re-authenticate them periodically. I think the default is like 3,600 seconds. But we could change that. If we wanted to set the interval for re-authentication to something other than the default, we could set that for a shorter or longer period. Or we could configure those parameters up on the AAA server, the ICE server, and then the re-authentication would be based on whatever's configured on the ICE server. And in this default state, our ICE server is pretty much generic. It has the username of Bob. It knows about the network access device, the switch, at its IP address, and what password to use. And beyond that, virtually everything else is at its defaults. The next thing we're going to do inside this interface, which is gig 0/7, is we're going to specify that it's going to be an authenticator. That's the role it's going to play. And we're going to do that with the command .1x PAE, which stands for Port Access Entity Authenticator. So when this port comes up, it's going to be automatically sending out an extensible authentication protocol request saying, "Who are you?" And if a supplicant is sending messages into the switch can take the appropriate responses to communicate with that supplicant. If we make a request or if we have an authentication that doesn't go well with the supplicant, how long should we wait before we go ahead and try again? We can set the .1x timeout transmit period. In this case, I'm going to set it to 10 seconds. So based on your environment, you have the option of making that longer or shorter based on the needs of that device and the type of device that's connected and how long it takes to react and so forth. Now we currently have the authentication open set on this port. So even if there's no supplicant or the supplicant doesn't authenticate correctly, it's going to be fine. But once we remove the open, the authentication we want to specify to be under the control of .1x. So whether we're authorized and allowing traffic through that port, or the port is unauthorized based on an unsuccessful authentication, we want to let .1x control that port. And the syntax to do that is authentication port-control auto. And just for grins, I think it'd be fun to do a debug. Let's do a debug of radius authentication, and then we'll go ahead and bring up that port. We'll do that with a no shutdown. Now the reason it's still showing us down is because on gig 0/7 that goes out to a laptop that I've got, the PC, I've got that port on the PC currently disabled, so it's not supplying any link, and that's why the switch port is down. So the port is not administratively down, it's simply down as a result of no link. So we could do a do show interface status, press enter, and there's our gig 0/7 right there. Currently it's got a default VLAN assignment of 1, and we are not connected. That's because there's no link coming from the PC. So let's get out of configuration mode and let's do a show .1x all. And this is pretty cool. It shows us that currently we have port 0/7 configured as an authenticator. The values that's shown here, the ones that we did not supply, are the default values for 802.1x on this version of a switch. And by the way, the version of switch I'm running is 15.x. And if you ever have a question regarding, okay, does my switch support these commands in 802.1x? A great way of figuring out the features that are supported on a certain platform with a certain version of software is by going to cisco.com/go/fn, which stands for Feature Navigator. By using the Feature Navigator, you can identify based on your platform and the software exactly which features and functions are supported by that combination of software and hardware. So in preparation for doing this video with you and talking with you about 802.1x, I thought to myself, how can I demonstrate how to use the supplicant if the supplicant currently is not connected to the network? And so here's what I decided on doing. So I've got the switch. There's switch 1. There's port gig 0/7. I've got the laptop connected right there. And what I did was I leveraged two network interfaces that this device has. So I have a wireless connection, which I'm going to be using RDP with, Remote Desktop Protocol. So you and I are sitting right here at this computer, and I can RDP to manipulate the supplicant, and then we can take a look at the results of what happens with that supplicant as it supplies the credentials to the switch, who is then talking with the ICE server. Now in your home lab environment, if you have a computer that's physically right next to you, you can just go ahead and physically go to that device to configure the supplicant without needing to do RDP to a second IP address on that device. So let's bring up our RDP session. This is the laptop that's currently sitting connected to port gig 0/7. If we go to the control panel for the network interfaces on this device, here's how we're currently looking at this machine. There's our RDP session over the wireless, and this connection right here is the one that is connected to gig 0/7 on the switch, which we just configured that port for 802.1x. Now, before we enable this interface, and bring it up. If we want 802.1x to work, we need to have the 802.1x services running on this Windows workstation. And for this demo, I'm currently using Windows 7. However, the supplicant feature has been around in many earlier versions of Windows, as well as the more current versions of Windows. So if we want to manage the services that are currently running on this computer, there are several ways of getting there. One of those methods is to go ahead and run the command services.msc. And you could also navigate to the services through Control Panel if you wanted to as well. And then from here, we're going to go ahead and scroll down, and what we're looking for, let me make this a little bit bigger, is we're looking for Wired Auto Config. And there it is right there. So regarding Wired Auto Config, if it's not currently running, you'd want to go ahead and start it. And in the future, if you want this to automatically start, you'd also want to configure it to go ahead and start automatically when the PC boots up. And those are the two changes I made to the Wired Auto Config on this Windows computer. So regarding Wired Auto Config, if you right click and go to Properties, or if you double click on it, it brings up the properties. You can specify the startup type, and you can also go ahead and click on Start if it currently isn't running. So with the Wired Auto Config enabled and running, our next step would be to go ahead and bring up that interface. So here's my wired interface. I'll right click on it, and let me enable that interface. Now at the moment, I do not have the 802.1x supplicant feature enabled on that interface. So for my Windows host computer, simply thinking, okay, great, interface is enabled, I'll boot up, I'll do a DHCP or whatever the interface is configured for, and life goes on. However, if we look back at the console of the Switch, it's not so happy. And that's because it said, okay, I'm starting .1x. So the link came up, the interface changed to up. It sent out a request saying, hey, I'd like to talk to you. Can you tell me who you are? And even though the Windows supplicant software is running, I don't have it enabled for 802.1x authentication on the interface yet. So here we have a message saying, hey, there was no response. So it gave up on the .1x, and the port is now open. And that's because we had the authentication open statement. And after a little bit, it's going to go ahead and try again. And then after a little bit, it's going to go ahead and try again. In fact, what I think would be fun to do, if we go back to our Windows client and we bring up Wireshark, and let's capture the packets on that interface, and we can actually see the EAP requests. So with Wireshark running, I'm going to go ahead and select this interface, which is the interface that's connected from the laptop over to port gig 0/7, and we'll start a capture. Now, as a result of being in VLAN 1, and there's a boatload of other stuff in VLAN 1 here in my office, we're going to have a whole bunch of traffic, including, look at that, we got some spanning tree running as well. But what we're going to be looking for is EAP traffic. So if we go back to the switch for a moment, we can see that it's trying over and over again. And then in our capture, if we wait long enough, we'll be able to go ahead and capture the EAP requests that are coming in since the moment that we started the capture. So if we go back to the capture, and let's go ahead and do a display filter. Let's look for EAP. And there we go. Yeah, we got 3 EAP requests. So I'm going to stop this capture for a moment. And if we take a look at the details of these EAP requests. So the MAC addresses that it's showing here and layer 2 for the source and destination are my Cisco switches, which is the source MAC address, and my Dell laptop. And so the first 6 characters, this first 24 bits of the MAC address are assigned to those vendors, and Wireshark has a table that says, oh, these first 24 bits is this vendor, and it's simply doing the courtesy of showing me that it's Cisco and Dell respectively. Here it's indicating that the payload of this Ethernet header isn't IP, it's not IPv6, it's not .1Q, it's not MPLS, it's 802.1x. And specifically, if we look at the payload, it specifies that it is a request. So this is the switch asking the laptop, hey, who are you? And at this point, it's simply a one-way conversation because I don't have 802.1x turned on at the client yet. So what I'm going to do is I'm going to start a brand new capture on this port saying, hey, what about the old one? I'm going to say continue without saving. We'll go ahead and go with the new one. I'm also going to type in clear to go ahead and remove the display filter. Also, if you have not yet explored and worked with Wireshark, I would encourage you to carve out a couple hours to go ahead and start looking at the Wireshark course. Also here at CBT Nuggets. The Wireshark course is fun and you'll get a lot of mileage out of what you learn from that course. And many students have told me that it's one of the best investments of time that they've ever made is in the Wireshark course. So with this capture running, I'm also going to click on the auto scroll button so it'll automatically scroll as new packets come in. We can also see those on the live screen. And I'm going to minimize that. And let's go back to this wired connection. We'll go to Properties, and there's a tab here for Authentication. And that's where we configure the 802.1x supplicant piece on a Windows client using the native tools. So to do that, we'll click on the checkbox that says I want to enable the IEEE 802.1x authentication. It's saying, hey, which method do you want to use? And there's a bunch of them. Look, there's Leap, and there's PEEP, and there's Microsoft PEEP, and I'm going to go ahead and use the Microsoft Protected EAP. And if we click on Settings next to Protected EAP, I'm also going to make sure that the Validate Server Certificate is off. Now in a production environment, we definitely want to validate server certificates as they are presented to us for the TLS. However, in our case, because the ICE server has a self-signed certificate that this computer knows nothing about, I'm going to simply remove that for the lab environment so that my supplicant won't shrivel up and hide when that server presents its self-signed certificate. So the outside tunnel is going to be Protected EAP. And as far as the selected authentication method, let's go ahead and click on Configure next to Secured Password. And I am not part of a domain. This Windows 7 computer is not part of a Windows domain. And I do not want it to go ahead and use my Windows login name. I'm currently logged on to this computer as admin. So I'm going to make sure this box for the lab environment is not selected. That way I can manually configure the password and username I want to use for the authentication and not have it pull that from my Windows computer. So with that checkbox deselected, I'll click on OK and click on OK here. And there's one more area we need to go to, and that is additional settings, so we can specifically tell it the username and password to use as part of the 802.1x process. So we'll click on additional settings, and here we have the option for user or computer authentication, just user or guest. And I'm going to specify user authentication and then click on the button that says Save Credentials. And the credentials we're going to have it save as part of the supplicant are the credentials that our ICE server knows about, which is only one local user account on the ICE server, and that is Bob. So we're going to put in Bob and the password for Bob. So whatever we configured for the password for Bob, which was capital NUGGET bang23, we're going to configure that same password here. And we'll click on OK. And OK again, and OK a final time to save it. So now in the background, this thing is already attempting to authenticate because we sent out a message. So if we look at the console for the switch, because we have debug radius authentication running, there is a boatload of output regarding the authentication that's currently happening. And it may take a few seconds for all of that information, although it's already happened, to finally get to the screen. So while that finishes displaying to the screen, let's go back to our Windows computer and let's bring up Wireshark, which is still running the capture, and let's go ahead and now do a search for EAP. So a quick display filter that will display just EAP related packets. So in the capture, there was a whole bunch of requests going on, But as we scroll down, we have some additional activity. So this is traffic going from the Dell over to the switch. Then we have some information regarding EAP TLS from the switch to the laptop. Again, if you want to look at the details of that, we can extract that. So what appears to be happening here is this offering, hey, you want to go ahead and use EAP TLS, and the response back, which is in this next frame. If we look at the details of it, it's saying, nah, I don't want to go ahead and use EAP TLS. So if we look at the details of that response frame, the Dell machine is saying, you know what, I'd like to use PEEP instead. And that's because that's what we configured our 802.1x supplicant to go ahead and use, was PEEP. So then we have some additional chatter, and then look what it changes to. Now we have TLS. This is the ICE server certificate being presented to the Dell client. And if we dig down far enough into the details, we can actually find the details for that certificate. So right here we have the common name ice.nuglab.com, which is the self-signed certificate. We can expand that. And as we continue expanding, there's the public key information for that digital certificate. And then as the client sends information back to the server, it can use the public key of the server to encrypt the data so that we have confidentiality for the balance of the negotiation. And then once they negotiate a session key, they can use symmetrical encryption to encrypt the rest of their traffic going back and forth between the server, which is ICE, and the Dell laptop. The payload is all encrypted via TLS. And because it's encrypted, it's now protected against anybody who might be eavesdropping or looking at that data, which is one of the benefits of using protected EAP. So let me tell you what I want to do with this. I'm going to click on Stop to stop the capture that's currently still running. And then I'm going to go to File and Save. Now currently there's almost 4,000 packets, and a lot of that might be other network stuff that I have going on. If we just want to capture the current information shown by the display filter, which is EAP related, what we can do is click on this radio button, Displayed, and then as we save the files, it'll just have the 31 packets related to this display filter, and that's all that will be there. I will take this and I'll save it as part of the Nugget Lab files for your reference. So we'll call it EAP Packet Capture, and I'll be sure to bundle it as part of the Nugget Lab files for this course. Now back at the switch, if we scroll through a lot of this output, which is here because of debug radius authentication, let's just point out a few highlights. So it knows the username is Bob. The service type is framed. We're taking all the data from the supplicant regarding, for example, the username and so forth, and we're encapsulating it and sending it over to the AAA server, in this case the ICE server, acting as the authentication server. Here's the framed IP address. That's because we told it we wanted to include that as part of the authentication request. So that's the IP address that's currently on our Windows computer, 192.168.1.12. And let me share with you how the debug radius authentication can be very, very helpful. Let's say we did our test. We tested AAA basic connectivity from the switch over to the AAA server. We know that's working. But yet our supplicant isn't working correctly. Well, that's a great reason why we're going to use open mode to start with, right? That way, if it doesn't work, we're not cutting off the port and they can still work. But secondly, we could use debugs to take a look at the details of what's coming through. And if it came through, for example, and said host instead of Bob, that would be a great reason why we're not able to authenticate a user if we don't have a user called quote-unquote host. It's very likely that the supplicant is sending over the wrong information for authentication of the 802.1x. And because this does generate a boatload of output, you'd want to be very, very careful in a production environment about doing anything that would generate so much content. Specifically, you also would want to avoid sending it to the console. Maybe send it to a syslog server or to the buffer, and then refer to the syslog server or the buffer to see the output. It also is a good idea to turn it on and then turn it off very quickly, because that could chew up a whole bunch of resources, and if you're at the console, it could tie up your console until the output stops. So I'll go ahead and turn off debugging with an undebug all. And if we need to turn it back on later for troubleshooting, we will. But also right here at the switch, if we do a show authentication interface gig 0/7, here's the MAC address of my Dell laptop. There's the method we use for the authentication. The domain is data as opposed to voice. And here we have the status of our authorization, which indicates it was a success. A slight variant on that, we do a show authentication sessions interface gig 0/7. And that also indicates that it was a success down here at the bottom. There's the IP address that client is currently using. There's the username. There's our current mode that we came in under, meaning if we had 3 or 4 different MAC addresses, they would all need to be authenticated and authorized. It was authorized by the authentication server, which is our ICE server. And we haven't yet pushed down any policies from the ICE server regarding Bob, but as we start pushing down policies, the information such as VLAN will show up right here. In this video, we've identified several different flavors of the extensible authentication protocol that can be used as part of 802.1x. We also identified that once we authenticate a user, we can actually push down policies to the port where that user is coming in for things like VLAN assignments or dynamic access control lists and other aspects regarding that specific user and their access into the network. We also taken a look at the different modes for 802.1x and how many MAC addresses have to be authenticated based on the type of mode that we're using. Our action items for this video are simple. I would strongly encourage you to lab this up, get that hands-on practice in your own little test environment, and get comfortable with the ideas and the concepts of 802.1x and verifying that it works. If you need to review this video a couple of times as you do that, please feel free to do so. The basic configuration of ICE was in the previous video, and the basic configuration for the 802.1x on the switch was in this video. Again, I've had a great time. I'm so glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.